Thank you. Thanks. Huge honor to be here. Last night about midnight, I started throwing up and purging basically out of both ends, got some food poisoning. So if I sit down in the chair, that's because I'm about ready to spiral in and vagal out. So just so you guys know with that. And also, this talk arguably should be about an hour and a half long. We have 30 minutes, so there's gonna be no foreplay or cuddling. We're just jumping right into it. So I've been noodling on this idea about metabolic flexibility for a long time. And it's interesting because I almost, now after Dr. Eid has gone, I wanna go back in and change my thing because I'm kind of making a case that there's not a one optimum diet. And then after her presentation, I'm like, oh man, I think I wanna change this now and completely redivert things. But again, I've been noodling on this idea of metabolic flexibility for a long time, and we'll get into what exactly that is. But the thing that inspired me to dig into this, it was kind of interesting. Some of my, well, I'll say my best discoveries. My wife will say I'm still an idiot most of the time, but I find most of my best things when completely by accident. And so I put optimal into the Google search window. And then if you notice down towards the bottom, nutrition was one of the things that spontaneously popped up there. I'm like, optimal nutrition. That's kind of interesting. That's something we should probably be, should be important. And what's really funny is the only people who ask the question, what is optimal human nutrition? It's the lunatic fringe. It's us. It's like paleo, low carb, and then we have our good buddy from Vegan Land, nutritionfacts.org. These are the only people concerned with what optimal human nutrition is, and it is fascinating. I scoured PubMed, the greatest repository of biomedical research ever accumulated on the planet. There's nothing. Nobody even asked the question. So I don't know, again, if we're just fruitcakes and we're just scratching around trying to find something that doesn't exist, or these other folks, because of financial interests or a lack of curiosity, just don't even ask the question, but it's really not going on. And not to steal too much of my thunder right out of the gate, if we were to ask, is there an optimal ancestral diet? My answer is no. There's not a singular optimal ancestral diet or human diet per se. And knowing my audience, there's probably a uniform intake of breath and puckering of backsides when I say that. But hang with me here. I'm still in good company. But I just kind of want to reorient the way that we frame a lot of these questions, because I think that some of the ways that we've gone after trying to even ask questions, the hypothesis generation process, has kind of led us down some blind alleys. So I want to point out some cultures, and you guys are, I'm sure, super familiar with this stuff, but there are quite a number of cultures with diets that work. And by diet, I mean the nutrition that they eat daily, not the thing that they're trying to do after the first of the year. So just so we're clear on that. But we have everything from the Inuit to the Catawans, Okinawan. Many of these people are considered to be in the, what's called blue zones. They're really interesting in that they do have some very interesting commonalities, largely whole unprocessed foods, a host of lifestyle characteristics that are very uniform and consistent. We're going to talk about that more at the end of this whole kind of discussion. But what's really oddly missing is uniformity in macronutrients. You look at the Catawans on the one hand, and they're upwards of a 70% carbohydrate diet, mainly from tubers, and then the Inuit could not be more different than that. But pretty uniformly, what they have as far as outcomes, which I think is the thing that we need to focus so much more on, both clinically and also from our research perspective, which again, Dr. Eid was talking about that just a few minutes ago. When we focus on the outcomes, when we look at these kind of blue zone populations, these pre-Westernized populations, they're largely free of Western degenerative disease. They die from something eventually, and it usually is something like heart attack or stroke or something like that, but it happens much later in life, and they have what's called a compressed morbidity curve. So they tend to stay quite healthy, and then they die. I'm not excited about dying, although I thought I was gonna die last night when I was throwing up, but if you've got to go, I would rather go quick than this long, protracted kind of deal. So this is what we see within these cultures. Now, by contrast, the cultures with diets that don't work, that's pretty much us. The Y processing, increasing palate complexity, this is kind of the thing that drove me to Wired to Eat, the neuroregulation of appetite and whatnot. I think is really where the rubber hits the road with so much of this process, because if we can, it's funny to me when researchers say, well, if we just get people to eat less, then they'll be healthier. And it's like, that's right. And that is pretty damn hard to do under most circumstances. And particularly in our modern world, we have a dedicated engineering devoted to making food hyperpalatable. And this thing just popped up. It just so blows my mind. So this bag right here could be a 1-hour talk alone. So it just makes me crazy. So Doritos roulette, which I think is an amazing thing. It should be Russian roulette. But if you look at the little blow up, it says, attention, some chips are very hot. Now what they're doing, they're creating a palate experience that is variable within a single bag. So I shot these guys an email and I said, hey, I just want to know, do you know about what the frequency is of the really hot versus the medium hot? Does it by chance follow a power law? And about a day later, this gal shot me back. She said, our scientists were very impressed that you were aware of power laws. And yes, it does follow a power law distribution. I'm like, okay, great. So the people who are profiteering from our disease use evolutionary biology, evolutionary psychology to formulate these foods. And they use chaos and power law mathematics to make them as addictive as possible. And the gatekeepers, for the most part, are medical professionals. If you threw these concepts at them of hyperpalatable foods, power law distribution to enhance the addictiveness of foods, they would look at you like you had 3 heads. So we really, really have our work cut out for us. And again, on outcomes within our population, I could pick a million different slides. This is just one of them. We see exponentially increasing problems. We see exponential increases in the cost of dealing with these problems, and on and on. You guys are pretty well steeped in that. So the case that I'd like to make is to focus on optimal outcomes and not necessarily optimal diet. Now, clearly, the dietary input matters, but I think if we reorient things to focus on what is the outcome that we want, and then we steer the boat towards that direction, then a lot of interesting things are gonna kind of play out in that story. So I'm gonna make the case that there probably isn't a specific optimal macronutrient ratio for the vast majority of foods, for the vast majority of people, but there is a situation or a few situations where some specific macronutrient ratios that are pretty tightly guarded are valuable. And the following with that would be high-level athletics. Part of the reason why I ceased working with high-level athletes is they were largely neurotic. Apologies for the high-level athletes in here, but I found it much more gratifying to help people who their lives were potentially going to be dramatically shortened or made worse because of metabolic health issues. With athletes, my main job was acting as a speed bump to prevent them from killing themselves through the process of training. But we had to get serial killer consistent with their nutrition. And if you've followed anybody in the physique or kind of fitness competitor world, it is crazy how incredibly repetitious these people are to achieve the body composition changes that they need to achieve to be successful. So that's an obvious situation, high-level athletics, physique competitors, and whatnot. Another situation in which it's probably a good idea to have a fairly tight rein on the macronutrients that are going in. It relates to everything that a low-carb or a ketogenic diet benefits. Gut dysbiosis, mitochondrial insufficiency, and insulin resistance / substrate insufficiency, which those last 2 pieces, mitochondrial insufficiency and substrate depletion, those are going to be kind of the main focus of the talk here in a little bit. But I would argue that even though on the one hand I'm saying there's not an optimum for everybody, for so many of us, the one tool we have is that low-carb or ketogenic diet ultimately. And then finally, of course, the key to fat loss is kind of what I was joking about just a little bit ago. The real trick here is creating a dietary regimen and a lifestyle in which people spontaneously reduce food intake and they hit some sort of a healthy norm. But that is not always the easiest thing to affect in people. So there's an assumption we need to make, or I'll make the case for it, that if there is an optimal human diet for humans, whether it's high carb or low carb, we should see some metabolic and genetic predilections for this specific approach. Now, this is where there may be a little bit of a hip fake that I'm doing on you guys, so don't start throwing tomatoes too early in this thing, but I'm actually gonna make the case that humans should be able to eat a lot of carbs and shouldn't suffer deleterious effects to that. Humans, there's a gene called the amylase gene. Humans, relative to all other primates, have dramatically greater amylase gene frequency and density than any other primate by almost an order of magnitude. And what we see here is the high starch cultures are in gray, the low starch cultures are in red. And what we tend to see in that scenario is high starch cultures tend to have increased amylase gene expression within that population. What's fascinating to me about the amylase gene story, so amylase is we have pancreatic amylase and salivary amylase. Salivary amylase is that first line of digestion of starch. What's fascinating to me is that the amylase gene frequency not only enhances the digestion of starch, converting it into sugar to make it available for digestion, it enhances pancreatic function so that phase 1 insulin release manages that blood glucose response. So it's not just throwing us under the bus with like, hey buddy, here's a giant bolus of carbohydrate, good luck dealing with it. It actually, in the people for whom this particular set of genetics works well, they're able to break down that starchy substance beginning in the mouth, they're able to break it down later in the digestive process, and they're able to manage it in a way that their blood glucose levels look very, very nice. Their blood glucose levels look the way that mine look when I eat low carb, and that's a pretty important thing to pull away with that. So what about ketosis? So I'll flip to the other side of the story. Is ketosis the default mode for humans? And again, this is where people may put my head on a pike and run out the door, but just hang with me here in a little bit. I'm gonna make two cases that ketosis is not the default mode for humans from a dietary input specifically. Intermittent fasting, exercise, a host of other situations can augment that state. And I do think that ketosis has been a constant companion of humanity for at least a couple of million years. But here's my point with this. The body really tries to get out of ketosis. So a shameless plug for my Keto Masterclass, this is some of the support material that we have for that. But if you look at the vegetables there, that's about 25 grams of effective carbohydrate, the amount of carbohydrate that would hit your bloodstream, and the pancreas would need to consider it, when trying to sequester it into our bodily tissues. That's quite a bit of vegetable matter, but it wouldn't be that hard to overeat beyond that. And God forbid if you threw carrots or beets in there, all of a sudden, you were completely out of the ketogenic state, at least for some people. Again, exercise, intermittent fasting, and some genetic variations can change that a little bit. So it's relatively easy, even eating super low glycemic load carbohydrates, to eat one's way out of ketosis. Now, an important question that I think needs to be asked more often is, does that matter? And it's not frequently asked enough nor answered with enough dexterity. If this was an hour and a half talk, then we would be able to dig into that, but it's a half-hour talk, so we're not. And then the tortilla, one of those and you're out of ketosis, right? So it's relatively easy to eat one's way out of ketosis. So that's just kind of intriguing to me. From the protein side, I hope that we've evolved to a spot where we no longer equate protein with chocolate cake. It can upregulate gluconeogenesis, but it is a reality that one can eat themselves out of the ketogenic state by consuming more protein. I will throw out the question there, does that matter at all? And really what it comes down to is #context. So if ketosis were the preferred metabolic state, why is it so hard to maintain? Why does the body kind of want to kick itself out of that? It's kind of a razor's edge to maintain that. But my understanding of this story to some degree is just because there is a certain metabolic inefficiency with being in the ketogenic state. You've got to convert these fatty acids into ketone bodies. There's a little bit of an energetic loss. And our metabolism being frisky about wanting to survive, it wants to steer us in directions where the full metabolic throughput is getting us the most energy that we can get. Although there are kind of exceptions to that, which I'll share with you here in a minute. So the second case against ketosis, the Inuit largely do not use ketosis. Due to CPT1A, carnitine palmitoyltransferase gene alterations. This is a really fascinating gene alteration, and it has the most rapid penetrance in human evolutionary biology of anything other than possibly sickle cell anemia. And it's fascinating what it does. It prevents the Inuit from even, with the carriers with this polymorphism, from even being able to enter ketosis. What happens is they're much more efficient at both protein metabolism and also direct fatty acid metabolism. But it increases hypoglycemia dramatically. Infant mortality rates within these populations are increased by a factor of 3, but despite that really powerful Faustian bargain, it still is incredibly valuable for these folks. But a historically ketogenic, or thought to be ketogenic population actually developed a super rapid genetic alteration that takes them largely out of ketosis. They can't even enter ketosis for the most part. And then this is a fascinating paper, and I do have all this stuff linked, and it'll be on robbwolf.com/talk, so you guys can grab all of these. I think there's like 100 references in this talk, but I just love this quote: evolutionary impacts on health might be more prevalent than currently appreciated. Amen on that, yeah. So carbs are good, low carb, bad, right? Nope, not at all. Context. Again, context. Here's the deal. And this is kind of the back and forth that I've seen, where people will develop stories around like, okay, humans are genetically wired to be low carb, and then other people will say, no, humans are genetically wired to be high carb because of the amylase gene. And from where I'm standing, it doesn't matter what the historical context is, which is kind of ironic given that I'm like the paleo diet guy and really like to inform my thinking with evolutionary biology. But at the end of the day, what matters is clinical outcomes. What are we able to do to affect the changes that we want in people so that we don't have a sick and astronomically increasing cost of dealing with our population? The reality is that we don't have any, for the most part, none of us have the blood glucose response or the hormonal responses that we see in pre-Westernized populations. And that's a really important consideration. There are clearly laudable characteristics of time-restricted feeding, exercise, low carb intake that all feed into this story of metabolic flexibility. Somehow I just wanted to get some sort of an Al Pacino thing in there. And so this concept of hysteresis is fascinating. And this is one of my favorite papers of all time, Glucose Hysteresis as a Mechanism in Dietary Restriction, Aging and Disease. If you search Secrets of the Lac Operon, LACOPERON, that's this paper. It is fascinating. And what it talks about is the way that metabolic substrates, as they make their way through our metabolism, the way that they interact with our genes and the way that they promote gene expression in various ways. And so much of what we are dealing with in our modern world is this hysteretic response, which is a memory response. Anybody that's an engineer, has some engineering background, they might have heard of a Schmidt trigger, which is something that we see frequently in electronics. But basically what we have is an input. This is a dynamic adaptive system, and this will make sense in a second. I'm setting this thing up here. We have an input that leads ultimately to an output, but what's fascinating about this on the genetic level is that it can be a very nonlinear system, and I'll show you what I mean by that. So when we start becoming sick, when we see mitochondrial dysfunction, when we start heading towards this glucose-centric metabolism that is largely incapable of metabolizing fat or generating ketones in an effective way, it's because we have sent a signal to our metabolism, to our genetics, that basically turns on that glucose-centric genetic machinery. Now, the numbers I'm using here are completely arbitrary, but what's interesting is this thing will turn on, but it will only turn on the glucose-centric metabolism when it hits an arbitrary level of, let's say, 5. Once our metabolism hits this scenario, we are in glucose metabolism. That's it. And so the fat that we consume tends to get accumulated non-alcoholic fatty liver disease, builds up as triglycerides in the blood. When we have sent a signal that's so powerful to our system that it has ratcheted the genes for glucose metabolism on, then it has turned a bunch of other things off. Now, what's interesting about this, and really shines a light on why a ketogenic diet or even some degree of fasting is really powerful, in this hysteretic story, it's a memory circuit. And the memory here may not get turned off until a very low level. And so, again, these numbers are somewhat arbitrary, but that genetic expression is 100% on until the glucose throughput is an arbitrary number of 0.3. So the story here is that it takes a long time to turn it on. Once it's on, you need almost no glucose throughput to turn it off. And this is why we see people play around with maybe like a zone mixed diet ratio, and they get a little bit of success. They do a little bit of low carb, a little success. They do some ketosis and maybe some alternate day fasting, and magic happens. And this magic is the hysteretic switch that gets flipped. And it's something that's incredibly underappreciated in the vast majority of medicine. Now, the kind of long-term significance of this story is that when we are in that glucose-centric metabolic state, all of the byproducts of glycolysis tend to go through the mitochondrial complexes 1, 3, 4, and 5. Those are significant, and they tend to produce a remarkably high reactive oxygen species byproduct when you put nutrients through that process. By contrast, if we are in a fat-centric or maybe a low insulin load metabolic profile, our glucose throughput and our fatty acid throughput, for the most part, is being managed through the pentose phosphate pathway, and the output for that tends to go through mitochondrial complex 2, which is a remarkably low oxidative stress output. So what we see here is that that high glycolytic throughput for folks tends to be a pro-aging, pro-inflammatory story. Now we see this kind of played out at a macro level. The average population is this green line, which is a shortened average lifespan. It's also an extended morbidity mortality curve versus what we see in masters athletes, that blue line there. And clearly not all athletes, but this is a pretty consistent feature of masters athletes. They tend to maintain more metabolic headroom or metabolic flexibility as they age, and they have that longer average lifespan and a compressed morbidity mortality rate. They live a long time, they get sick, they die in a matter of a couple of weeks. We can see this with the respiratory quotient. The respiratory quotient is kind of when we track the oxygen consumed versus the CO2 expressed in an individual either at rest or at work. If they're very glucose-centric, then they tend to see a respiratory quotient of 1. Fatty acid-centric tends to be a respiratory quotient of 0.7. Interestingly, Kenyan runners and other folks like this, even though they eat a very high starch diet, their respiratory quotient actually is closer to a fat metabolism than it is to a carbohydrate metabolism, and that's because they are not flipping because of whatever circumstances, which we'll talk about that here in just a minute, whether it's gut health, mitochondrial flexibility, what have you, but they are tending to still see more throughput going through that mitochondrial complex 2, which is low oxidative stress and has a host of other upsides. By contrast, we see people, this is metabolic inflexibility and insulin resistance in adolescents with non-alcoholic fatty liver disease. Folks that are heading towards that type 2 diabetic state, their respiratory quotient is effectively 1. It is glucose-centric. And again, that's a high oxidative stress environment, lots and lots of problems with it. So is there a formula for success? Is there something that we can pull out of this that we can use? And I'm going to argue that there's not necessarily like a number. Optimum isn't a number. It's going to be two kind of matrix-driven processes. The first one is that under ideal circumstances, we should be able to transition seamlessly between a wide variety of fuel substrates. If you had a big whack of carbs, it wouldn't leave you drooling on yourself a couple hours later. If you had to go a day without eating, like I did because I had some food poisoning and I haven't eaten all day, and what I did eat from yesterday didn't stay with me all that long, and it would be largely unaffected because I've been in a ketogenic state for a long time. So it's not that big of a deal for me. So I would argue, though, that a seamless transition between fuel substrates is a laudable characteristic, and it's something that we should be pushing for all the time. We should always be pushing for a little bit more metabolic headroom, the ability to deal either with a little more carb or a little more fat, although there are situations in which that really tightly controlled macronutrient ratio will be valuable. The other point that I'd make is optimum is going to be a relative lack of modern degenerative disease. And I don't think there's really any huge drama around that. I will make the point that when we're talking about the lack of modern degenerative disease, it's really important that we pick our definitions of what normal or healthy is carefully. So this is an example of, let's see, is there a laser pointer on here? No, maybe not. But the top one is a United States population. The bottom is a pre-Westernized population, and they're basically being checked for oral glucose tolerance. And what's so interesting with this is that even though this non-Westernized population on the bottom, they do see a mild decrease in their ability to metabolize glucose with age. So they're losing a little bit of metabolic flexibility. At the end of their life, they're better than anybody was in the Westernized population early in life. So when we are trying to define what normal is, we need to be very careful. And that is a place that I think that the ancestral health model, evolutionary biology, can be really valuable. This is our normal 2-hour oral glucose tolerance test. And we don't really get all that concerned until it's up above like 140, 160, heading into 200. We're type 2 diabetic. By contrast, I got this information from Stefan Guyenet, a couple of blog posts he did pertaining to oral glucose tolerance tests in pre-Westernized cultures. And what's interesting is this is a 1-hour oral glucose tolerance test. The other one is 2-hour. This is what we use. The 1-hour oral glucose tolerance test, in general, pre-Westernized individuals barely go above 100. And that's in half the time. And I would make the case that the 2-hour oral glucose tolerance test and anything that we ascribe as being normal or in that pre-diabetic stage, the house is burning down. Like we have serious, serious problems. Some of the work that we're doing with LabCorp is looking at the LDLP, LPIR score, and glyc-A as it all relates to this early diagnostic around prediabetes. And it's interesting, many people with an elevated blood glucose, 100 to 110, never progress to type 2 diabetes. They do have some other problems due to that elevated blood glucose level, but they never progress to type 2 diabetes. But there's a subset of people that will run around for a couple of years with blood glucose around 90 to 99, and then they rapidly progress to type 2 diabetes. There's interesting hows and whys around that. But this whole story of prediabetes is really just it is so ignoring a problem that is really incredibly powerful. This stuff has kind of macro application. How many people are familiar with this work from the Weizmann Institute? They were put oral glucose, continuous glucose monitor on 800 people, track their responses to various foods. Again, this could be a big one to jump in and dig into. But the graph on your right-hand side, is that right for both you guys? Yeah. That is different individuals and their blood glucose response to bread, the same amount of bread. And look at that. The bottom one, they barely have a blood glucose response. You have some people that are up in that peri-diabetic range due to consuming this food. What we learned out of this study, and these are kind of cool, blood glucose response to bread or straight up glucose, and then bananas versus cookies. And some people, the cookie produced, it's like they drank water and then a banana made them diabetic. So this stuff is really kind of crazy and also important from the perspective of personalized nutrition. I know for all of us trying to convey a general recommendation that we can get the most people on board with, eat largely whole unprocessed foods. Okay, check, that's great. But even within that story, there is a massive variation both from person to person and how a single individual reacts to various foods. I have like 3 minutes left here. So the real world example of this is the 7-day carb test, which I featured in my second book. The 121 is my wife's blood glucose response to, I think this was white rice. 190 was mine. This was at 2 hours, which arguably may be too high for both of those, but clearly my wife's blood glucose response is dramatically better than mine, and she's like 40 pounds smaller than I am. So just from a dilution factor, you would expect her blood glucose to be a little bit higher. If she was the same weight as I am with the same metabolic health that she has, it would probably be even better than what we have here. Another real world example is the transition into ketosis, and how some people experience the low carb flu, I think that those people, like me, tend to be on that insulin resistant side, have been in that kind of glucose-centric metabolic machinery for a long time, and it's really like a bug hitting a windshield. But again, interestingly, my wife, she doesn't notice transitioning into ketosis. She'll go low carb, she'll fast, she is completely unfazed by this whole process. And that's another interesting thing too, is the people that I find who do easily transition into ketosis, they don't have that magical, the angels are singing, my brain works super, super good. I think it works for the other folks like myself who maybe have some broken metabolic machinery, and it really is bypassing some of the logjam that a glucose-centric metabolism. So why can't we transition seamlessly into a ketogenic state? This largely boils down to mitochondrial damage in various ways. And this is a super short treatment of the various inputs that can damage the mitochondria. I could have had dozens of these, but antibiotics are a potent disruptor of mitochondrial function. We forget sometimes that the same RNA and DNA that we go after with bacteria and antibiotics, mitochondria are endosymbiotic bacteria that we've been carrying around for a very, very long time. Mitochondrial dysfunction and obesity. The very state of obesity tends to be a high oxidative stress environment. We have a massive throughput of energetic substrates that overwhelm the mitochondria and cause oxidative stress. Iron overload, oxidative stress, insulin resistance, sleep dysfunction. So we look at, I think 40% of our population now, our work population, is in shift work, and it's crystal clear that shift work causes a host of metabolic disruptive processes, and really at root cause is mitochondrial dysfunction. The gut microbiome can negatively alter mitochondrial function. And this is a great paper. It's about neuroimmune and neuropsychiatric disorders, and it details the many roads towards mitochondrial dysfunction that lead ultimately to these conditions. So your metabolism ultimately is your mitochondria. And again, just making that point down in the bottom left-hand box, if your mitochondria are broken, the only thing left is glycolysis and effectively complexes 1, 3, and 4, which are high oxidative stress and carry all kinds of other problems. This is something that I would love, again, like a longer format to talk a long time about. Multi-generational epigenetic changes. What if my grandmother had gut dysbiotic issues that influenced my mother, and then my mother, who was type 2 diabetic and also autoimmune, what knock-on effects did that have? And all of these things seem to be heading towards mitochondrial dysfunction and an inability to really have a flexible metabolism. Okay, we just have to see Arnold skewer this guy. Enough talk. Okay, I have 50 seconds, so we'll see if we can get this done. Okay, so what the heck do we do with this stuff? It's all the things that we talk about all the time for restoring our general health. Circadian rhythm, sleep, light exposure, I think are massively underappreciated, but are really coming on strong. This is probably one of the most important things that I've done in the last year, which is by hook or by crook. If I won't freeze some part of my body off, I go out in my backyard in Reno and sit in the sun for as long as I can in the mornings. I have some pictures of me being out there at 19 degrees, and even if it's like 30 seconds, it's made a huge impact on me. Gut health, meaningful relationships, lift weights, go fast, go slow. What that means is get a wide variety of physical activity. Novel experiences are great for the metabolic flexibility within the brain. Regarding food, I just really powerful argument to track your blood glucose response. Use that Wired to Eat 7-day carb test. And just as an aside, the last chapter of the book is on ketosis. The whole book is a funnel for getting people into ketosis. Not many people realize that, but they're like, hey man, I went through all this rigmarole and ultimately it looked like ketosis was a good fit. And I'm like, yes, it was. So, but you're an asshole if you tell people you can't eat carbs, but if their own metabolism says you can't eat carbs, then they're good. So. Eat with the seasons, get as much variety as possible. How many people know the story of Procrustes? Anybody? Procruste in bed? We've got a couple of them. So Procrustes was a kind of an outlaw in Greek mythology, and when he would encounter people on the road, he would offer for them to stay in his abode. And the Greek mythology is really odd in some ways. But what he would do to people, if they were tall, he would stick them in a short bed and cut their legs off. If they were short, he would put them in a long bed and like put them to the rack. But basically a Procrustean process is where you bend and flex the truth to fit your desired outcome. And I think that all of us, myself included, have used this kind of Procrustean process to try to take just so stories and create this overarching kind of like, oh, high carbs best or low carbs best or whatever, versus making the bed work for us. And that's where a focus on outcomes is really where the rubber hits the road. But again, using this ancestral health perspective to have that kind of steeping in what normal is and what healthy is. And I think 3 minutes over. I'm super sorry. We're excited. Thank you guys so much. And I didn't pass out, so that's awesome. Thanks.